Okay, Unit 6 is all about graphing what we call linear equations. Will you guys look at that word linear really quick?
Linear, like line.
Very good. Linear is like line, which means we're not graphing parabolas, we're only graphing lines right now. Okay, so just straight lines.
Are lines easy?
Okay, lines are a lot easier than parabolas. Okay? Okay. Today for 6.1, all we are doing is kind of introducing the graphs and the parts of a graph. We will start graphing using the simplest method, which is using a table. And we're also going to determine whether an ordered pair is a solution. So first, let's look at the parts of a graph. Okay? We have multiple parts on a graph. There's first these two lines, right here and up here. These are called axes. Which way is the x-axis? Left to right or up and down?
Left to right.
Very good, left to right. So let's label it. And so the up and down is the y-axis. Okay. Does anybody remember what the entire graph is called?
A graph.
A coordinate, we call it a coordinate plane.
I was going to say grid.
It is a grid because of all the little boxes, but sometimes when we draw them, you know, when you draw it, you don't draw all the little boxes, right? So we call it a coordinate plane. Okay, and then one really important part of the coordinate plane, the part where we always start, is called the origin. What are the coordinates of the origin?
0,
Good job.
I'm smart. I'm smarter.
Okay, 0, 0. That's the origin. Okay, so really quickly, when I am graphing a point, I always start at the origin 0, 0. And do I count x's first or y's first? X's. So I go along the x-axis, let's say 1, 2, 3, 4. And let's say I go up 1, 2, 3, 4, 5. And I put a point there. What would the coordinate of that be? Wait a second. I went over 1, 2, 3, 4. 4, 5. Very good. Okay? What if I went to the left 1, 2, 3 and went up 1, 2? Negative 3.
Negative 2.
Positive 2. What if I go to the left 1, 2, 3, 4, 5 and I go down 1, 2, 3, 3? Negative 3, comma, or no, negative 5, comma, negative 3. Good. Okay? So those are all different ways to graph our points and the different parts of the graph. So let's define what an ordered pair is. An ordered pair is a point on the graph that has coordinates x and y. We write them with parentheses around it because that tells us that they're together, and we write them x, comma, y. So the x term is always first, so we always count the x first, and then we count the y second. Okay? Alright, so now we want to graph lines, but we're going to use a table first to start graphing these. So step 1, graphing with a table. Step 1, we plug the x value into the given equation. They're going to give us all the x values. So we're going to plug the x value into the equation. And then step 2, we will solve to get the y value. Who said that? Plot the point. Step 3. Okay. So step 3, we plot the point. And then step 4, we connect all points with a straight line. Okay. And remember also, guys, lines, do they stop just where your points stop, or do they go on forever? Lines go on forever. What's it called when it stops? A line segment. Okay, we are working with lines right here. So we have to make sure that when we graph them, we draw arrows at the end to show that they keep going. Okay? Alright? So these are lines. They have arrows at the end, which shows that they go on forever. So let's do an example. Example 1. Okay, we are given the table and the graph. So step 1, we want to plug in the x value to the given equation. So all we're going to do right here is we're going to plug in -2 for x. Okay, the x is on the far left column, sorry. Here's your equation right here, 3x minus 4. So all we do is we plug in the x value for x. So all I did was rewrite it. Now we're going to solve it and write the answer in the y column. So what is 3 times -2? -6, and -6 minus 4 is? -10. So in the y column we're going to write -10. Okay. And then, so what would, the last column is x comma y, which means they want us to write what the point is. So what would the point be?
Wait, hold up.
Good. -2, -10. So this is how you fill out the chart. So how would we do -2, -10?
Go down.
1, 2 to the left, and down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh man, 10.
Let's make a fake one.
Yeah, let's just pretend. Okay. The graph is.
Draw another row of boxes.
If you want to draw another row of boxes, that's okay. Okay, so my next x value is -1. So we're going to plug that into the equation. So this time it's 3 times -1 minus 4. Right up here. Here's your equation at the top of the chart. Okay.
It'd be -7.
So if we plug it in, 3 times -1 gives me -3.
So it'd be negative
Minus
7.
4 is -7.
I was right.
So what's my point there?
-1, comma,
-1, -7. So let's graph that. -1, 1, 2, 3, 4, 5, 6, 7.
Connect them.
Not yet. Okay, what I want you all to do is, will you finish the table? So do the last 2 x values and plot those points, and then we'll connect them.
Are we doing?
Okay, ladies and gentlemen. Okay, so I plugged in 0 for x here. 3 times 0 is 0. Minus 4 gives me -4. So the point was 0, -4. So I stay on the x-axis. I don't move at all. And I go down 4 spaces. Okay. For x equals 1, I plug in 1. 3 times 1 gives me 3. Minus 4 gives me -1. So I go over 1 and then down 1. So I should have 4 points, and they should all be in a row, right? Okay, so let's connect it. Do it as straight as you can. Extend the line as far as you can, and make sure you put arrows at the ends.
As far as you can.
All right, you guys good? Okay, example 2. I want to do 1, and then I'll let you all do it. Okay, example 2. Same idea. This time we have a different equation. What's my equation this time? 1/2 x plus 1. So what I'm going to do is I'm first going to plug in -2 for x. So 1/2 times -2 plus 1. Okay, and ladies and gentlemen, let's think about it. What is 1/2 times -2?
1.
A positive times a negative gives me a negative. So it would be -1 plus 1, which gives me 0. So what's my point there? -2.
I don't get what you do with halves. I don't get what you do with it.
You just half it.
Okay.
Half whatever's in there.
Yeah. Multiplying by 1/2 is the same as dividing by 2. Gentlemen, for my chart. So my 3 points that I need to graph still, 0 positive 1s, which means I start at 0. Do I move right or left at all?
Right.
X is 0. I don't move right or left at all. But I go up 1 space. Okay? What about 2, 2?
Oh, that's
Over 2,
yeah, over 2.
up 2.
Next one you go over 4.
Over 4, up 3.
If the X is 0.
Yeah, if X is 0, you don't move left or right at all. Okay, so that should be a straight line, so let's draw it. And there you go. Make sure you draw your arrows. Okay, so now that we know how to graph using a table, we also want to be able to determine if a point is a solution. Okay? So step 1, we are going to plug in the x coordinate for the x value, so for x, and the y coordinate in for y. So what's going to happen is they're going to give us an equation and a point and ask, is the point a solution? So we're going to have an x and a y, so we plug those in. Step 2, we simplify. If the statement is true, then the point is a solution. Okay? So that means we're doing this algebraically now. We're taking the numbers and we're plugging them in. Okay, now if we get a true statement, solutions are also points on the line.
Well, is this going to be factoring?
There is no factoring in this, no. Okay, let's look at our previous example really quick, okay, and see if it answers your question. Okay, so what's going to happen in these problems is they're going to give you an equation that looks like 1/2 x plus 1. Y equals 1/2 of x plus 1. And then they're going to give you the point -2, 0. And ask you, is this a solution? We're going to plug in -2 for x, 0 for y, and see if we get a true statement. If it's true, which it should be, that means that that point lies somewhere on the line. So this time it's kind of like them giving us the line and we have to find the points. So it's going backwards of what we just did. Okay? But this is all algebraically.
This is easy.
Okay?
I just did the first one without your help.
So example 1.
You probably got it wrong number.
Okay, I gave you 2 different wordings of how the questions are going to sound so that you're used to what it's going to ask you. Okay? Example 3. Determine whether the given point, 3, 7, is a solution to the equation y equals 3x minus 2. So all I do, like I said in step 1, we plug in x for x and y for y. So what am I going to plug in? Where am I going to plug in 3? The x. So it's going to be equals 3 times 3, right? The minus 2 stays. And what goes right here? 7. Okay? Okay, so all I do is where I see y, I put in the second point. Where I see x, I put in the first. Okay? Now let's simplify this. Okay? So we get 7 comes straight down equals 3 times 3 is 9 minus 2. And so we get 7 comes down again. 7 equals, what's 9 minus 2? 7. Is that a true statement? Yes, it is true. Okay? So is a point a solution to the equation? Yes.
So we gotta do all that for one problem?
Okay? Look at example 4 then. Example 4, it's worded a little bit differently, but it's asking you the same thing. Does the point 4, -5 lie on the line represented by the equation 6x minus y equals 10? Okay? So plug those in and see if you get a true statement. Okay, so will somebody tell me what they got after they plugged everything in? Ashley?
No.
Oh, not the answer. Tell me how you plugged it in. 6 times 4 minus, and y is what?
Negative.
minus negative 5
Did you get the final?
Is it okay if you plug it in as positive 5?
equals 10, as long as you change that to a positive 2. Okay. Okay. So now we have, first thing we have to worry about is we have minus and negative, so what happens? Positive. What's 6 times 4? So we have 24 plus 5 equal to 10. 24 plus 5 gives me 29 equals 10. Is that true? No. So is this a point, does it lie on the line? No. So this is what it's saying, guys, really quickly. Okay, if I were to graph this line, so we could make a table and actually graph the line, right? If I were to graph that line, the point 4, negative 5 is actually on that line. That's what it's saying. Does that make sense? Okay.